Hello, everyone. Oops, sorry. Hello, everyone. Thank you for tuning into today's Tech Talk. This is our third of 6 events in this series. And today is all about LEDs and how they power plant production in our greenery container farms. My name is Caroline Katsarubis, and I'm Freight Farms Director of Marketing and Community Relations. And I am joined today by my colleague, Derek, who is our lead industrial designer. Hi, Derek. This is a quick overview of our agenda. We're going to start with the basics of why we use LEDs, because that's a great place to start. And then we'll dive deeper into the actual technology, covering power and photosynthesis, how we've designed the LEDs to be dynamic to suit your individual needs, and then the purpose of the color that we use. That's often a question that we get. And then after that, it's all about how the LEDs are controlled through our farm automation software farmhand, and then we'll wrap up with some customer examples and the most important, a live Q&A session at the end. So as questions come up, please feel free to drop them in the Q&A feature on your Zoom panel, and we'll get to them at the end. And this whole thing is going to be recorded, so if you feel the need to just like tune in and not jot everything down, you'll be able to review it later. And without further ado, I'll pass it over to Derek.
Awesome. Thanks, Caroline. Thank you guys all for joining us today. So let's get right into it. First of all, it is important to cover why exactly we do utilize LEDs or light emitting diodes. There's lots of options out there for many different growing environments that you'll see many different grow systems utilizing usually 3 different types of lights, mainly incandescent or fluorescent, halogens, and then of course LEDs. Just to cover those other 2 really quickly, incandescents it's what you see in your house for the most part, and most of your bulbs and your lighting fixtures. They operate by heating a filament till it glows, and that produces the light. These are super inefficient though, as only about 10% of the energy that they consume becomes that visible light. And the other 90% is wasted heat from just heating that filament. Halogens are pretty similar to incandescents in that sense, but they contain a tungsten filament that creates a tungsten vapor, and that will mix with a small amount of halogen gas and deposit back onto that filament. So this does extend the lifespan of the bulb itself, and allows it to operate at a much higher temperature, which results in an increased light output. These are slightly more efficient than incandescent, converting about 20% of the energy they consume into visible light, but that other 80% is still wasted heat. And they're also quite a bit more dangerous as they utilize a quartz envelope, or instead of glass, it's utilizing quartz, which is sensitive to temperature, oils, touch. So you can imagine this could result in bursting bulbs or a lot of failure points. And with that tungsten filament and that halogen gas, that's not something you want in your growing environment. And lastly, LEDs, or light emitting diodes. As I said, they produce the longest lasting, most energy efficient lighting available today. It utilizes a semiconductor that's rich in electrons and a semiconductor rich in holes, and those are used to create an LED. So passing a current through the junction of these 2 materials combines the electrons with those holes and produces photons. Photons are just the unit of light that you can see. And some of the advantages to LEDs include that they are 80% of the energy they consume becomes that visible light, compared to the 10 and 20% of halogen and incandescents. They run cool because of that. They're not heating that filament to create that light, which requires less energy to physically produce the light, as well as less energy to offset the heat that's created by the light itself. They're shatterproof and contain no dangerous filament, mercury gases, or toxins, none of that stuff that we want in our growing environment. The color itself can be customized, while a halogen or incandescents are limited to that sort of orangey yellow color, which is relatively full spectrum, but it's only providing a fraction of the wavelengths of light that the plants are actually utilizing to grow. So even in that 10-20% of light output, you could be losing almost half of that to wasted wavelengths of light. So the color customization is a pretty big thing, being able to identify exactly what we want. The lifespan is just way better, with most LEDs nowadays having a lifespan of about 50,000 hours. And that's 40 times longer than incandescents and about 15 times longer than most halogens. And unlike incandescents and halogens, the LED technology is constantly being improved and upgraded to be brighter, operate cooler, and more efficient. So it's just the right technology for the application. Next, for us to really understand the advantages of our system and then the way that we harness the benefits of our LEDs, we're going to take a quick step back into grade school and refresh our memories on what photosynthesis is and the role that light plays in it. So photosynthesis in its simplest sense is the process of converting light energy, CO2 and water, into glucose and oxygen to utilize to build cellular structure, aka grow. It consists of three main processes. One, the roots of the plant absorb water and minerals and bring it to the leaves through tissues called xylems. Carbon dioxide and oxygen enter and exit the leaves through pores called stomatas. And then finally, the part that we're really interested in is the individual photons, that's the unit of light, are absorbed by a pigment in the plant. That pigment is what makes it green, and we all know that as chlorophyll. That light energy is transferred to an electron. The chlorophyll will transfer that light energy to an electron, which will then, through a process called the electron transport train, one of the best names ever, it will lose its energy through a series of reactions that capture that energy in necessary ways to keep the plant living, mainly generating glucose to fuel more cellular development, aka to grow bigger. Since photosynthesis is dependent on light energy, we have the ability to actually control the rate of photosynthesis by manipulating the intensity of the light in our farms. It's possible because light and photosynthesis have this very direct relationship. So if you double the amount of light reaching your plants, you will double the rate of photosynthesis, aka the rate of growth. More light equals faster, bigger growth. But when I talk about the amount of light that reaches the plants, it's important to understand the quantifiable unit that we use to measure that amount. So that unit is called ppfd, which stands for photosynthetic photon flux density. It's a mouthful, but it's the measurement of the photosynthetic active radiation, which is PAR for short, or in its simplest sense, it's the visible light that plants use for photosynthesis. And that visible light on the wavelengths is 400 to 700 nanometers on the lighting spectrum, which is shown here. You can see. So we're really interested in only measuring that amount. So compared to something like lumens, which most of us are familiar with if we're going in to the hardware store to buy a light bulb or a flashlight, that's going to tell you the amount of light actually being produced from that bulb, where PPFD considers the amount of light actually reaching your plants. And so this is a pretty important distinction, especially in a growing environment where we're most interested in the light that's actually reaching our plants. We don't care about any light that doesn't. So the more photons, or those units of light, or a singular aspect of light reaching your plant's chlorophyll, means more energy being converted to food, which results in faster growing, larger, more robust crops. But that relationship is maintained only up to a certain point, and right around 350 micromoles per square meter per second, that relationship plateaus, and the more light energy that you put into your crops doesn't result in a greater rate of photosynthesis. Instead, there are many other factors that become relevant to increase the rate of photosynthesis, namely presence of CO2 and a few others. But yeah, the lighting relationship really drops off right around 350. And since the greenery LEDs are designed to maximize the rate of photosynthesis by generating light intensity between that 200 to 300 micromoles per square meter per second, depending on your chosen light mode, there is really minimal wasted energy. So we're really coming right up to that plateau mark without exceeding it, and honing in on exactly what the plants are able to absorb with our specifically engineered LEDs. So what this results in the Greenery S is in our high range or our performance mode, which we'll talk about in a minute. It provides about 60% greater light intensity and 50% more efficacy in our lighting systems than previously in our previous iterations. But to fully take advantage of this increased power and efficiency in the Greenery LEDs, we created 3 distinct lighting modes designed to give you full control over every aspect of your grow. So you see here, the different modes are defined by their DLI. There's a lot of terms to learn here, but when talking about LEDs, it is pretty important to understand all these units. So DLI stands for Daily Light Integral, which measures the total amount of light per day. So this is taking into account the intensity of the light, or the PPFD, amount of light that's reaching your plants, and the duration, or the amount of time that the plants are actually being exposed to that light intensity. And so those two together create your daily light integral. So within our performance modes, you can see, with our standard mode, we have 12 DLI, the economy mode at 9 DLI, and the performance mode up at 18 DLI. So whether you want to provide custom lighting environments based on your crop type, some crops actually have less chlorophyll than others, which results in less of an ability to absorb that excess light. So you don't want to be giving them more light than they can absorb. It kind of comes back to that plateau mark on the graph that we showed there. Every crop is slightly different. That's definitely sort of the rule of thumb, at 350 micromoles per square meter per second. But depending on the crop, there is a chance that they're not able to even absorb that much light. So being able to dial them back for those specific crop types is important. Also, whether you want to, speed up or slow down your harvest. So there's many instances where you have a customer that may want delivery on a certain day, and the way that your crops are trending, you need to catch up a day or maybe even slow down a day. So by being able to fine tune your DLI to these different presets, you're able to really kind of control the crop harvest schedule on your schedule and make it work with all of your customers. Other opportunities are to fine tune your energy consumption to your needs. So if you're operating, say, off of renewable energy, you're probably not going to be running your farm off of your performance mode. You're probably going to want to take advantage of maybe the standard or eco mode to really be able to subsidize as much of your energy with that renewable, or even completely run it off renewable in an ideal scenario. And then lastly, we have the ability to kind of mimic a more natural light exposure, so mimicking that rising and setting of the sun, which gives the plants a chance to wake up a little bit and not be shocked into their lighting environment. This dynamic control of the Greenery S gives you the ability to hone in on all these ideal settings. So another huge, really the last aspect that we're going to talk about here of our lighting system is something I mentioned a minute ago, but has huge potential for continuing to adapt your system to your crops. And that is the Greenery's ability to isolate and control the saturation of our 2 different wavelengths or a color of light. So the Greenery utilizes a blue light, which is 440 nanometers on the lighting spectrum, and a red light, which is 660 nanometers on that lighting spectrum, as these are 2 colors that fall within that PAR range, that visible, usable light range, and are proven to initiate photosynthesis in all plants. But each color does provide a different reaction for the plants, or does draw a different reaction out of each plant. And so being able to isolate those and utilize them is really important in the Greenery, and really exciting in the Greenery as well. So with red light, which is naturally more prevalent in the summertime, it triggers a hormone in plants that keeps its chlorophyll from breaking down. And so we've learned that the more chlorophyll that you have, the more light energy it can convert into food, and therefore the more plant matter it can generate. So by maintaining that chlorophyll, that red light is ensuring that your crop is going to continually to grow as fast as possible. This is especially important for certain crops like fruiting crops, as the development of the fruit is critically reliant on the chlorophyll operating at that maximum capacity. Now, blue light, which is naturally more prevalent in the winter, it triggers a different hormone. This hormone slows stem and leaf growth as it does not protect the chlorophyll in the same way as the hormone triggered by that red light. Now, this seems probably pretty counterintuitive. Why would you want to slow down the rate of growth? Yet it's hugely important in creating more dense and vibrant crops, especially when growing certain things like leafy greens, your lettuces, your herbs, your brassicas. Why? Because creating a rich, hardy head of lettuce is primarily the result of this hormone triggered by blue light, really keeping that head of lettuce dense, color rich, and leaf matter robust is strangely an effect of that counterintuitive nature. It makes sure that the plant grows to the shape and size that you would expect to see on a grocery aisle. Now, the color of the light also plays a role in the stages of growth. So when our nursery LEDs are fully on, meaning we're turning on our blue and our red diodes, they're providing a ratio of 4 red to every 1 blue, while our cultivation area provides a ratio, when both the red and blue are on, of 5 red to every 1 blue. Now, this is designed like this for the reasons that we just kind of talked about. We want slightly more blue light in the nursery area in order to tell that plant to focus its growth on its roots, as that system development is really crucial for the plants in these initial stages of growth to ensure a successful transplant and transition into that vegetative state of growth, which is going to be its high growth rate stage of life. And it really is dependent on that root system to be able to draw up all the minerals and nutrients it needs to power and really take advantage of the light that it's being that it's receiving. Now, subsequently, we use more red light in the cultivation area to drive that leaf and fruit development. So once we have that root structure really solid, really built in a way, I say built, but grown in a way that is ready to uptake all those nutrients, we want to send those nutrients to the leaves, send the red light in, and just tell that plant it's time to grow. But like I said before, we always have the ability to isolate either color for any duration to develop a unique ratio for whatever might be growing at a given time. So that 5-to-1 ratio is really just when you're operating your lights in full red and blue mode. But by transitioning to just blue and just red for different durations, you're able to, as a collective, change that ratio to whatever you may want. Now, all of this control of these lights is powered through our FarmHand software and app. Now, FarmHand will provide you with a preset lighting recipe or multiple preset lighting recipes based on a variety of our canon of crops, those most sold, those most grown crops within our Freight Farming Academy. It'll allow you to choose from these 3 modes: your eco, your standard, and your performance power modes. And it'll allow you to continually test, adapt, and save different recipes with custom settings as you get to know your farm, get to know the plants that you grow more often, and you can really fine tune that lighting environment exactly to those plants. All of these features, excuse me, give you complete control to unlock your plant's full potential, whether that be by kicking your farm into that performance mode to be able to harvest just weeks after seeding and speed up that development of that plant. Fine-tune your energy consumption to meet your budget or to run off renewable, like I mentioned, or customizing the color intensity of your LEDs to drive production or coerce certain and unique characteristics out of your plants. And of course, there's much, much more that farmers are continually discovering every day. We're just providing you with the tools, and you guys are really the ones that unlock some of the coolest features and some of the coolest crops I've ever seen have come from people really playing around with these different lighting modes and lighting wavelength customizations.
Awesome.
That's sort of in essence, yeah, that's kind of an overview of all the different aspects of what drive us to use LEDs and how they really power, quite literally, our farm into growing some of the most exceptional crops in the world.
Amazing. That was so much information and really helpful. And we talk so much about the technology within these tech talks, but it's really also amazing to put it into perspective by showing it the actual technology in action and thinking about why do we use LEDs. And I know we covered why from a technical perspective, but you have to think about the actual local food production on a global scale. It's really impossible to do in a lot of areas that don't have full days of sunlight. And we have multiple customers that was kind of a main driver for why they got started, because it's impossible to grow traditionally in a place like Sweden or Washington year round because of the limited daylight hours. Some of these places have as low as 4 hours of sunlight at certain times of the year. So watching the technology in action is really where we get super excited. And then this specific case study on the left, Harvest in Sweden, they're going to be our customer case study focus in our Grow Foods Here series. And that will be launching in the next week or two. So please keep an eye out to hear all about their specific operation in Sweden. All right, we've been getting a ton of questions, which is not surprising at all. I feel like I have a ton of questions after listening to you talk. So let's dive into those. Okay. So you mentioned that I think the question is around R&D and how exactly are we evolving the technology year over year? Can you talk about that process and how exactly are you measuring the efficacy or the impact? How are we finding that sweet spot that you were talking about?
Yeah, so it's kind of a combination of things. So one, because LEDs have become so universally used, there is some really top-notch institutions and organizations out there doing, intense studies on different wavelengths and the way that different crops respond to them. So a lot of our initial R&D or information that we base some of our designs off of were from some of those institutions, and I'm sure we can dig up some of that information for you guys if you're interested. But then second sort of phase of that is that once we have sort of a baseline of what we want to use institutional knowledge that's out there, we don't want to reinvent the wheel for stuff that's already been done, but then we take that information and we apply it to our application. I mean, we have some very unique aspects of our system, whether it just be form factor and being in a small condensed space such as a container. Certain things like efficacy is incredibly important because we need as little heat output as possible so that you don't spend all of your money cooling your farm. So sorry, in short, it's a lot of institutional knowledge out there that we've harnessed and have worked with really great partners to get a baseline of what we want. And then it's getting samples, getting as many different varieties of lighting scenarios, wavelengths that we can get in-house, and testing, growing, eating some delicious and some not so delicious crops, and continuing to iterate on that until we really hone in on what feels not only right for the farm, but right for the customer and their ability to operate it in a way that makes sense for them.
That kind of, there are a couple questions about that customization of the crop's growth patterns depending on the farmer's distribution needs that you mentioned. So either slowing down or speeding up crop growth with the amount of light intensity that you're using. So how are these factors affecting the quality of the crop? You kind of mentioned like maybe the crop doesn't taste so good. What exactly would be going into that?
Sure. So, I mean, a huge factor of flavor in especially leafy greens is the temperature that they're grown at. So that's another huge reason that we utilize LEDs. Like, we could match the output of our light utilizing halogens or incandescence or fluorescence, but we couldn't do it without creating an incredible amount of heat. And that heat is going to generate some really sour tasting lettuces, and some other flavor profiles that might not be so appealing. So heat has a huge part of it. To answer the first part of the question, and that's why LEDs are quite amazing. To answer the first part of the question, though, when it comes to sort of fine tuning the mode or your light intensity for that delivery date, if you will, and some of the subsequent potential impacts that could have on the plant, really what we're doing is kind of just mimicking or creating our own weather. I mean, anyone that has a garden or whatnot, if you get a stretch of 2 really beautiful sunny days where the sun is out, no clouds in the sky, and you've got 12 hours of light, those plants are going to pop up those 2 days. And then if you get a couple days of cloudy weather, a couple days of rain, they're going to kind of hang out at the same size. Then that growth rate's going to slow. And we're just replicating that, but by just creating a brighter day or a not as bright day. So when it comes down to what impact it has on the plants, it really doesn't have any impact other than it growing faster or slower, just like it would out in nature under the sun. That's what's kind of so cool about it.
Yeah. And there are two kind of questions related to how you manage the heat generated by the lighting system. And then also if we supplement our crops with CO2 to speed up crop growth. And I'll let you touch on it briefly, but we did the segment, the Tech Talk series right before this was all about the climate controls with inside the farm. And we did something similar where we're talking about the CO2 and the air temperature control. So definitely encourage you to watch that as well.
Absolutely. Yeah, so like I mentioned before, most LEDs, depending on their efficiency, it's going to change slightly, but they will produce about 80% of the energy will become invisible light, while 20% or even less in a lot of cases in our lights, I think we're right around 16% will be turned into a heat load. And we offset that by utilizing a 3-ton all-in-one HVAC unit. So it does cooling in multiple different stages. It does dehumidification at a rate of 2 gallons per hour, and it does heating, which you're only going to utilize if you're in some of the most intensely cold areas in the world. But that paired with a ducted system that will deliver that cool air exactly where we want it and pull it back through our system ensures that we're creating that uniform environment over the plants, and offsetting that heat load from the LEDs. And in a lot of instances, though, we actually utilize that heat load for our benefit. So like I said, if you're in a cooler environment, you're gonna spend less on HVAC because you're gonna create a little bit of ambient heat from those lights, and it's actually going to help your plants maintain that. If it's lettuce, 55 to 60, if it's basil, 65 to 70 degree temperature. So there's some cool aspects there. And second part of the question was the CO2. We do supplement CO2, as I kind of touched on, but didn't want to go too in depth here, is the other aspect besides light that has a huge influence on the rate of growth is CO2. And so we are not going to be in the farm every day because this is a really sort of a low touch unit where a lot of the systems are automated and you're only in there at a maximum 20 hours a week. So us breathing out our CO2 is not going to supplement the crops enough. So we do have CO2 canister in there that is automated as well, and will work with farmhand to automatically release CO2 that will actually be fed right into our HVAC system through some ducted diffusers, and then that CO2 enriched air will be diffused over our plant canopy, so subsidizing that light with the CO2, creating that perfect environment for it to achieve its maximum rate of photosynthesis.
Great. I have a question that I do not know the answer to. This person is asking about how versatile and flexible imposing those different light regimens within one greenery. Can you have one side be operating in econ mode and the other side operating in performance mode?
Yeah, absolutely. So we do have within the farm, there are 3 distinct lighting zones, one of which is our nursery station. So that's a separate lighting zone for the reasons that we mentioned. Those seedlings require slightly different lighting environment than our cultivation area. Within the cultivation area, we separate it by grow row. So if you're familiar with the layout of our farms, there are 2 grow rows that have our plant panels sitting back to back with the lights on either side. So each of those grow rows you'll be able to light independent of each other. So if you've got lettuce growing on the left that you want to be that robust, hardy, dense head of lettuce, you can operate that zone on, blue light on your standard mode. And if you've got chives and basil that you're trying to just bolt them and stretch them as much as possible before harvest on the right, you can run that in full red blue mode at a performance cycle. So we do have the 3 distinct lighting zones within the farm.
Great. One last question that we cannot skip over as we're running right over time. Do you recommend users using grower glasses when operating in the farm while the LEDs are on?
Yeah, if you're going to be in there when the LEDs are on, I definitely would suggest utilizing grower's glasses. Anyone that's not familiar with that, that's basically just a pair of sunglasses with a green lens rather than a shaded lens, and that's going to counteract the red light so that to you everything looks normal. It's going to protect your eyes. But what's so great about the greenery too is that there really shouldn't be too many scenarios in which you're in the farm with the lights on. Usually, and everyone, again, you have the ability to turn them on whenever you want. But usually people utilize their day mode in their farm for their plants during the night time. So when you're not going to be in there, and that's for a few reasons. One, it's usually cooler at night, so you don't have to have your HVAC work as hard to offset that heat. 2, energy prices are usually cheaper at night too, so you're not spending as much on that. And again, you're not in there, so you don't have to disrupt your plant's lighting schedule to be in there and work.
Perfect. All right. Well, that's all the time that we have for today. Thank you so much, Derek, for all of the information that you've provided. Super helpful. And just a reminder to everyone, we will be sending out the recording for you to review. And we still have 3 more of these tech talks over the next couple months, alongside some really powerful customer case studies in our Grow Food Here series. So I definitely encourage you to tune into them in the future. Thank you all for spending a little bit of your time with us today.
Thanks, guys.
Bye.